Hello and welcome to Design Make Play TV. I'm your host, Zachary Anderson. For those of you tuning in for the very first time, here on Design Make Play, we seek to engage makers through challenges and discussion, to highlight maker projects, and of course to learn about the STEAM-based curriculum. That's science, technology, engineering, art, and mathematics. If you like anything that you see here today, make sure to check us out at zenmakerlab.com, where we offer a variety of programs and summer camps available for students. And in those summer camps, you'll be building some pretty cool project kits. But in the case that you're not feeling comfortable attending some face-to-face programs, there are always our project kits available online. So if you go to shop.zenmakerlab.com, you can go there and find our project kits. And while you're there, you can also pick yourself up some PPE equipment. Yes, ZenMaker Lab is now selling not only face shields, but soon to be including masks as well. So you can go there and you can find a variety of our face shields and soon our masks as well. So that covers most about that. Of course, we're trying to make this live stream as interactive as possible. So if you go ahead over to Instagram, you can Insta at us with the hashtag DesignMakePlay throughout the live stream, and I'll be checking my phone to make this as interactive as possible. Now, for those of you who have been watching this week, you already know this, but those of you who haven't, we are running a summer giveaway here at ZenMaker Lab with a variety of very cool prizes, some of them provided by the Vancouver Canucks. So we're very excited to have these prizes for this summer giveaway. Of course, we'll also be giving out some other things as well. But yeah, so let's go ahead, let's roll the clip. Let's go ahead and take a look at our very first project here, which is Clancy's Boat. Set sail for Impress, and this one is Jackson's R2-D2. Now this cannon was made by Oscar Hudson's Deluminator. Next up we've got Daniel's Dice. Check out Oscar's Lantern. Here, let's play some Keaton's Crossy Creek. So that is our summer giveaway. And of course, to enter for our summer giveaway, you have to submit your maker projects. So you can submit them to us via email, Twitter, or Instagram. With, of course, the hashtag DesignMakePlay, maybe hashtag summer giveaway. And if you send those to us, we might highlight them in our maker highlight segment. And that segment normally starts at around just after 9 o'clock. So if you want to tune in to see a couple examples of the projects that are being entered in today in our Maker Highlights, you can tune in just after 9 o'clock and you can find them there. So let's go ahead, or if you're watching this at a later period, it's about halfway through the show after the first half hour. Okay, so let's go ahead now and jump right into our segment for the day.
Hello and welcome to another segment of Design Make Play Show. My name is Aryan, I'm the designer at ZenMaker Lab, and today we're going to talk about 7 principles of design in design industry. Have your pencil and paper ready? Let's get started. So when we talk about these 7 principles of design, we're talking about the rules that we have to follow to get the result that we want in our designs. These rules are necessary to use in any sort of design, industrial design, art design, graphic design, web design, any sort of design world that you guys think of. So now let me demonstrate the first principle of design called pattern. So pattern is regular arrangement of shapes. When you see pattern like wood pattern or metal pattern, these are all patterns, right? So I'm gonna make an example in more simple way. So I'm just gonna try to draw shapes that's gonna arrange in the same way. So I'm just gonna draw one triangle, one up, one down, and then put circles in them, like that. So if I try to copy these arrangements again and again, if I put them all together, that creates a pattern. There are all sort of different patterns in design world. So number 2 is contrast. So what is contrast? Contrast is highlighting the difference between two things or between two shapes. So for example, light and darkness, or a really organic shape and really more pointy shape like a triangle and a circle. Or you can go even more further than that, like an old car and a brand new car. These are all make contrast. So I'm gonna make an example on my computer, really more simple way of explaining contrast. For example, if I have this circle, and have one side of it totally black, and one side of it white. So the darkness and the light is creating contrast. Or as I said, really organic shape and a triangle and a circle. This is creating a contrast. Number 3 is emphasize. So what does that mean that you're emphasizing on something? So emphasize is when you want to put attention on a specific thing. For example, if you have a bunch of circles in a paper and all of a sudden there is a small square in between them. So that's when you emphasizing on that square. So you're grabbing all the attention of your audience to that specific thing. Or for example, everything is in red and all of a sudden there is a blue dot in between. So you're grabbing the attention of your audience to that blue dot. So emphasizing is another technique we use in design world. So I'm gonna make another example for emphasize in design world. For example, I have a really fun one in here. So I have a bunch of people having a mutual face, like a poker face. I'm gonna copy them all. And all of a sudden, I'm gonna have one of the guys having a big smile on his face. So what I'm doing here is I'm emphasizing on the guy that having a big smile on his face. So our attention go towards him. Number 4 is balance. Probably you guys all know about balance. Balance is when two objects or two things are arranged symmetrically. So I'm gonna do an example in here too. So triangle, another triangle in here, another one. And another one like this. So this looks like balance, right? I'm gonna do another one. 2, 3. This looks balanced. Number 5 is proportion and scale. So proportion and scale is the relationship between the shapes and the objects. For example, when we talk about proportion and scale, we talk about how realistic it is for our audience. For example, if I try to draw, let me put an example for you guys. If I want to draw a human body, I can have his head so big and his hand so small. So I have to follow some rules, proportional rules, that I get the best results. So number 6 is harmony. So what is harmony? Harmony is arrangement that makes all the shapes as a whole. So one of the really good example of harmony, when you go in nature, in jungle, in desert, in anywhere that related to nature, you can see a lot of harmony. Harmony is actually used in music. When something sounds harmonic to you, it feels good and feels that everything really goes well together. So in design world, we have harmony too. So I'm gonna have some example for you guys for harmony. So if I have a circle in here, I have triangles pointing towards a circle. This is a really simple example of harmony. Or even these ones. I'm gonna make a few examples of harmony. Last but not least is number 7 is rhythm and movement. So what does that mean? So in design board, we have to have rhythm and movement too. In our drawings, in our film, in our photography, it should have some movement in it. So that was the 7 principles of design. Hopefully you guys can use these principles in your future work. Remember, you guys have to continue working on these principles so that comes to you unconsciously. So whenever you're designing something, you know that it should be balanced, it should be harmonic, it should follow all these rules to get the best results. My name is Aryan, I'm the designer at Zenmaker Lab, and hopefully you guys have a great day and take care.
What is time? And how do we measure it? You know, it was Aristotle who said that time is a calculable measure of motion related to before and afterness. Hello, I'm Clockery Anderson, and today we're going to be learning about time. What is it? How do we measure it? And in particular, we're going to be looking at replicable events and using that as a reference to make our own time. Let's get started. Can somebody lend me a hand? The sun, the beautiful sun. You know, before we even had clocks, most people would actually look to the sky to tell what kind of time it is, right? Is it bright out? Is it dark out? And we can kind of get an idea of what kind of day it is depending on where the sun is in the sky. But it doesn't give us an exact time. Now, we also have clocks in our bodies, right? And this is known as circadian rhythm. It's one of the reasons that it's so important to go to bed and wake up at the same time of the day. Okay, because your body actually has an internal clock that is telling it when to do things, energize, and when to sort of relax and refresh. There's a lot of processes that happen when you sleep, and your body has to do some prep work for that. So that's why going to bed and waking up at a regular time is super important. So we talked about how the sun can move around in the sky. Well, one way that we can tell time is actually using sundials. I've made a really poor sundial out here at Zen, but there's a variety of other ways that we can tell time. But a sundial is one of the naturalistic ways, right? And we talked about replicable events. So every time that sun is directly above, we know that a single day has passed. One way that we can tell time, rather than just using hours or our clocks, is we can actually find another event that happens faster than the sun raising up right in the middle of the sky, and we can use that to tell time. So what I'm gonna do is we're gonna make the assumption that I drink this cup of coffee at the same rate, okay? It takes me the same amount of time to always drink this cup of coffee, and I'm gonna stand right here for the rest of the day, and I'm just gonna drink my coffee. And we'll see how many cups of coffee it takes in a single day, and then we can use that to actually figure out time in terms of cups of coffee. Why not? You know, the 12-hour hands were actually just
used by the Egyptians. There's no biological reason behind why we have 12 hours in a day. It's actually just because the Egyptians like to count up to 12. It could have been 10. It could have been 100. So that covers that. Let's go ahead and let's see how many cups of coffee I can drink in a day from sunrise to sunrise. Let's get started.
Hello everybody and welcome back. Okay, so we were just outside and we were looking at the sun and we were trying to measure everything by cups of coffee. And now we've go ahead and we've had 288 cups of coffee in a single day. So let's go ahead now and create our own clock using the cups of coffee that we just had. Okay, so first we had 288 cups of coffee and we want to relate that back to the regular clock that we normally use. So we're going to go ahead and cut that in half because normally we don't use 12. We have 12 a.m. and 12 p.m. in a single day. So I'm going to go ahead, I'm going to divide that by half and we're going to go ahead and we're going to get 144. 144? Okay, great. So now we need to divide the 124 by 12 and to get that to relate back to our regular clock. Okay, so we're going to go ahead and do that. So we're going to take 144 and we're going to divide 144 by 12 and we're going to get to, oh, that's going to equal to 12. Look at that. That's fantastic. All right, so now we can go around the clock and we can figure out the times of the day in relation to cups of coffee that I drink every single day. Okay, so let's go ahead. We're going to put that one there. That's going to be 20, that's 24. All right, and then we've got 36 and we've got 48. Okay, we're going to go around like this the whole way and we're going to fill out this whole thing in relation to cups of coffee. Okay, so let's go ahead and do that. Okay, so we have 144 cups of coffee in a single day. So if we are trying to keep track of time in relation to me as drinking my coffee, then it's going to be about 144 cups of coffee. So as I drink my cup of coffee, then we can tell the time. So I can be a clock for you. But the only issue with this is I have to keep drinking my cups of coffee every single day at the exact same rate. And that's going to be a little bit difficult. So let's go ahead and we're going to take a look a little bit later at different ways that we can keep track of time so that I'm not caffeinated all the time. So thanks you guys so much for checking out this big segment and I hope to see you next one. Okay, so I just had a cookie and I'm feeling a lot calmer now. Let's go ahead and I'm gonna propose this challenge for you. So the challenge for this video is, I want you to devise your own timekeeping system using some sort of replicable event that's somewhere around in your house or in the surrounding environment. So for example, that could be how long it takes somebody to water the garden. See if you can figure out how long that would take for a whole day and then tell me what is that time in 2:30, okay, 2:30 p.m. All right, how many watering the gardens is that? So that's your challenge for this video. Hello.
Hey everybody, it's Coach Greg here with Coach Jammer. We've been in the play space with the Design Make Play show all week, learning about fundamental movement skills as it relates to soccer and physical literacy. That's kind of our theme here, is we're trying to create long-term athlete development and well-rounded, happy, healthy citizens. So utilizing soccer and your knowledge with the sport of soccer, doing all these drills was a blast. And today we're going to summarize our learning and incorporate it into what's our final day look like.
Oh, well, first of all, I've really enjoyed my time, and hopefully you guys have as well. And Greg, thank you for having me. It's been a blast. Yeah, today we're going to work on some fun games and some challenges for you, because after doing all those drills, we all want to get challenged and enjoy what we're learning to do. So we're going to work on that. So here we go. Okay, so we're going to start the first one, Greg, so if you can come back here with me. Again, we'll do a little bit of a warm-up and then gradually get into our games. Okay, so the first one is we're just going to jog out to the first cone,
Okay.
and back, second cone, and back, third cone, and back. Whew. Warmed up? Yes. Okay. So now we're going to use these balls. I'll go first. So I'm gonna put a ball on top of each cone, and then I'm gonna come back and you can go and pick them up.
All right.
So on your marks, get set, go.
Okay. So now I can.
Yeah, and then run it back. Back. Very good. You put those in there. Excellent, excellent. Okay. So now we're gonna remember how many percent of the game is played with our feet.
Okay. You were talking high 90%?
Yes.
99? 99?
Yeah, 99%.
Okay.
We use the feet. So we're gonna do the same drill. I'm gonna have these here. Maybe you can start. So, and then I'll retrieve them. So you're gonna dribble each of those balls to each of those cones, and then come back. So on your marks, get set, go. Be there. Good. Yeah, I'll do that. You go. Good.
Penguin?
Yeah.
Penguin?
Oh, good memory. Very good. Okay,
Okay.
so now what I want you to do, you're going to deploy 3 of those balls. Okay, so
Okay.
the first, you can go either to the third one or first one, it's up to you, but you're gonna go out, leave it on the side, come back, get the second one,
Okay.
and
No, I don't have to like balance it right in.
no, just leave it on the side, good, and
Yeah.
run back, good, and then go there, oh yeah, get it on the third one, nice, I like that spin, and then one more,
Slippery, this guy.
yeah,
Okay.
one more in the middle, good, and then come back,
Okay.
and I'm gonna go retrieve them. So I'm gonna go to the third one, ball manipulation, I'm gonna deposit it, second one, deposit it, third one, and deposit it. Whew!
Good challenge.
That one is, and you can also change it up. You can use your right foot or your left foot just to challenge yourself more.
Okay.
So if you knock one of the green balls, you lose a point.
Okay.
You got 5 points. I got 5 points. Ready and play. Good. Oh!
Oh, okay.
Now 4.
1-0.
Here we go.
Set.
Ready, good.
Okay.
4
Here
or
we go.
5. Good. Push that. Good. Yeah, keep moving your toes. That's it. Good. And good. And stop there. So we were having a lot of success. To challenge, just close the gate. Let's see how we do now. Good. Yes. We call these $1 million passes. Oh no, that's.
The ball didn't go off though.
I know, but it still didn't make it through. So 3 points. You still have your full 5. Nice. Oh yeah. 4-3.
Okay.
And action. Oh yes.
2.
So 3-3. And let's challenge ourselves even more. We're awesome. 3 points each. Oh, that was close. Oh!
All right.
2 points for you. Oh no, sorry. You're still at 3.
Okay.
Red, you're looking pretty good. Oh yeah!
Oh.
2-2. 2-2.
Thought I had that one.
Okay, this one is double. The next one who hits it goes down to 0.
Okay.
Ready and play. Really concentrate now. Nice. Oh, yes.
Too close.
Excellent. So, good job there. What do you think of that one? You like that game?
I like it, yeah. I like how you can progress it and make it more challenging, tighten those cones up.
Yeah.
But, and then having the ball sitting on top of the cone so that when you hit it, it goes off. That's a little interactive. I like that part of it.
Yeah.
Good challenging he was working on what you were teaching about passing. He was really trying to be conscious of, proper position, moving my foot back, proper position,
Yeah.
moving my foot back to home base. I like it.
Yeah, that was great. Excellent.
Okay.
You got three passes to see if you can get all 6 down.
Okay.
Ready and action. Whoa, that was
Three.
awesome. Oh, you're down to 3 now, Greg.
Okay, here we go.
Oh!
One lone soldier
That was
left.
your 3rd pass.
I think that was my 2nd.
Was it? Oh, okay. I'll give you a bonus.
Technically.
Okay, so here you go. One to clean it all up.
Okay.
Yes! Excellent. There you go, kids. Mission accomplished.
Okay, now it's your turn.
Okay, you laid it out. Okay, that
Your
was good.
turn.
Kids, let me see. I'm gonna see if I can do it in 1 pass. Okay? Never been done.
Going for strikes.
This one is, remember the weight of the pass, the accuracy of the pass,
Okay.
everything.
Pull him off the wall there. That's good.
Okay, and I'm gonna do it with my right foot. Right, here we go.
Oh, nice. That's 3.
Front 3, and now the back 3. Here we go, left foot pass.
Oh, he got
Oh.
stymied on that pass. Pull that
My
back
last
out.
one. That is
Okay.
tricky. How am I gonna get all 3?
That's the fun of the challenge. Look,
I didn't do it.
they didn't want to fall.
Okay, you're gonna give me one more? One
Yeah,
more
you
bonus?
get one more bonus shot.
I'm trying to get it to correct.
Oh, they weeble, they wobble, but they don't fall down.
That one was a tough one. So that
All
one,
right.
that one was a good one. You can always keep doing that over and over and challenge. You can increase your distance
Yeah.
and make it challenging. But you guys will really enjoy that, kids. Excellent.
I really enjoyed that one. All the challenges were good. The games were fun. Thank you, Coach.
That was great. Everyone did a great job.
It's been a fun week learning all about soccer, fundamental movement skills relating to soccer and physical literacy. We're all about multi-sport here at Design Make Play Show, and it's been fantastic having you here, sharing your knowledge and expertise. I learned a lot, and look forward to having you back for sure. So, what can you say about all that we learned this week?
Well, that's it. It's the skills. There's a bunch of skills to be learned. The ones that we covered this week were your basic drills that you can start at a young age, but you can still do those drills even when you're in your adult ages as well. So I remember growing up when I was younger in Ottawa, and I would come home from school. I would come and grab my soccer ball, and then I'd run out to the field and just practice for 2 or 3 hours. I used the wall for the passing component. I did dribbling. I imagined that I was a professional soccer player, and I would be like dribbling in front of thousands of people, and Jammer comes in and beats one defender, and then he shoots and scores, and I just had the best time ever. And that's how I ended up becoming a decent player, actually. So you guys can do the same. Go out there, enjoy yourselves, have fun, and always smile when you play.
Great. So again, I'm going to summarize that statement with focus on creativity, imagination, hard work, and you'll achieve all your goals in all your athletic endeavors. All right. So once again, thank you so much, and we'll see you next time on the Design Make Play Show.
Hello and welcome back. So we just finished a fantastic 3 segments on Design, Make, and Play, and now it's time for our questions. So let's go ahead and let's take a look at some of the questions that we're going to be posting today. Of course, these questions will be posted on Instagram, so you can have your chance to go there to Instagram and check out these questions. But let's go ahead and take a look at our first question, which is regarding the design segment. So for design, our question is, what's the seventh element introduced in today's segment? What's the seventh element introduced in today's segment? So that's your question regarding design. For make, what's the clock inside of our body called? What's that clock? What's the name of the clock? That internal clock called? So that's from the make segment. And finally, for the play segment, we have how many cones were left after Jammer's last challenge, last try. So how many cones were left after Jammer's last try? So those are your three questions regarding those three segments. You can go ahead over to Instagram and take a shot at answering those three questions. And if you get them right, maybe we'll give you a little shout out on the show. So that covers the first half of our show, but don't go anywhere, because next up we've got some tributes, some highlights, and a very special guest. So see you in like 30 seconds. Hello and welcome back. So first up, we have our engineering tribute. So this is a segment of the show where we do a little bit of research on somebody that has made a significant contribution to research or society as a whole. And it's not always an engineer, sometimes it's a scientist. But today we are going to be tributing Dorothy Hodgkins. And I know this is a little bit different from the schedule originally, but I thought, hey, let's do Dorothy today, just because why not? I thought she did some really fantastic work. So, who is Dorothy Hodgkins? What did she do? Let's go ahead and let's take a look. So, first things off, Dorothy was obsessed with crystals. And no, not with crystals that you like put your energy into and heal you. No, crystallography. So she was actually using X-rays and bacteria and viruses that were actually sealed in crystals. And she would shine these X-rays onto these crystallized bacteria. And that would give you like a sort of like a shadow, essentially. And that shadow would give you some idea of what these bacteria, what these viruses actually look like. And this was really, really important for coming up with a variety of cures and like antibiotics. So a lot of the work that she did was really, really important for the development of insulin, penicillin, and the reconstruction of vitamin B12, right? So some really important stuff and very, very cool. And for this, she won a Nobel Prize in 1964 in chemistry. So very, very cool. But what do these things actually do? So penicillin is actually used to treat a variety of bacteria. So a variety of infections caused by bacteria. So it's actually a really important discovery, right? And it's probably helped indirectly a large number of people, her work. So that's one reason that we wanted to give a tribute to Dorothy. The other is insulin. It's actually really important for people who can't regulate sugar very well. So if you know anybody that's maybe a diabetic, they're probably, or they probably are using insulin or some sort of system to regulate their blood sugar levels. And actually, one of my good friends, Sam, in elementary school had diabetes. He was born with it, unfortunately, so he didn't have a lot of control there. But he used to have to actually prick his finger and measure his blood levels, and then if they were too low, he would have an insulin shot to fix his blood sugar levels. Yeah, so Dorothy actually helped to develop insulin, which helped my buddy Sam. So thank you, Dorothy, for all your awesome work in capturing the structures of all these different bacteria and viruses. We really appreciate it. So let's go ahead and take a look a little bit about some of the things that Dorothy liked to do. So of course, she liked to play with chemistry sets at the age of 10, and she and her sisters would actually make all kinds of potions and concoctions and run some chemistry experiments, which was very cool. That was actually a pretty popular thing that you don't quite see as much anymore. These big chemistry sets that you could really do some really crazy stuff with back in the 40s and 50s. She also loved to draw. She loved to actually draw the beautiful patterns of some mosaic mirrors. So yeah, she was a bit of an artist as well. So thank you, Dorothy, for all the contributions that you've made to society and to research as a whole. We really appreciate it. So let's go ahead now and move into our Maker Highlight segment. So this is a segment of the show where we get to highlight some of the projects that have been worked on by students here at ZMA or submitted to us for our summer giveaway. So of course, a little bit about the summer giveaway again. So you can submit your projects if you're not already in one of the Zen Maker Lab Academies via Instagram, Twitter, or email. And if we like your project, we will host it here in our Maker Highlights for your chance to win some of the very cool giveaway prizes, some of which are sponsored by the Canucks. So yeah, we've got some really cool Canucks swag, some sticks, some hats. So make sure to enter in your Maker project with us today. So let's go ahead and take a look at some of the entries that we have today. And first up, we have David's turtle. So this is a turtle that was actually developed by David in the character design portion of our Maker Lab Academy. And so this is a turtle that he's put together, and it is a beautiful turtle. Look at that guy. He's got this big shell. He's got his little turtle hands, his little turtle feet. Fantastic. He's got like one eye that's a little bit bigger than the other. And actually, that people say that usually one eye is slightly bigger than the other. So maybe that's where he got the idea. And then we can see he's got some sort of little astro man that's sitting on the back of that turtle. So David's actually used two things in his design. He's used some clay, it looks like, to model this turtle, and then he's actually 3D printed a turtle master baby to ride on top of his shell. So very, very cool. And we can also do take a look here at Ryan's penguin. So Ryan's penguin here. This is a fantastic character. Let's just take a look there. And again, this was made in the character design segment of ZMA there. And wow, look at this character. This penguin is in disguise. This penguin is in disguise. He is like a spy penguin, I feel, because he's got his like yellow shorts on, he's got his yellow shirt on, and it looks like he's trying to impersonate somebody, but he's a fantastic penguin here. We can see that his body and his head are some different colors there, so we can pick that up. And then he's got like these lovely little yellow arms and yellow feet. And actually, that makes a lot of sense, right? Because typically we see that the feet of a penguin are actually a different color than the rest of its body. It's normally like an orange, right? I think that the wings of a penguin are normally like black and white, right? Or for a variety of the penguins that we typically see. And we've got some big, beautiful blue eyes, right? Because how else would we be able to see without our eyeballs? I think that those are very, very important. Not just your eyeballs are important, but also a variety of mechanisms in your brain. So your occipital lobe is actually at the back of your head, and that actually processes a lot of the signals that come in through your eyes. So yeah, of course your eyes are very important, but your head is also very important too. So make sure to take care of that. But fantastic job on your penguin there, Ryan. You did a really good job, and so we just wanted to highlight you on our show today. So fantastic work. Now, last but not least, we have Blue Stevens Radio. So this is a radio project that we worked on at Zen, and this was combining electronics, laser cutting, and 3D printing to make this really cool project. And this was sort of a group project where students had to design their own enclosures and knobs, and Steven did a really good job in trying to model the knob that would go on this radio. So when you're working with electronics, usually you've got a PCB board and you've got all these really nice connections, but then say that it's raining outside or you're moving it around. If you drop it, there's a lot of components in there that you might be upset if they broke. And if it's raining outside, well, you might short something, and that would not be so great. So typically you want some sort of enclosure around the devices that you're using. And so that was the challenge given to these students. So after they were done putting together this big, beautiful board, then they had to design the enclosure that would go around it. And so Stephen designed a knob to actually go on this radio here to adjust the variable capacitor. So on your radio, you typically have some sort of resonant tank, a capacitor and some inductor that you are tuning to a specific resonant frequency. And that's how we pick up specific channels. And so you need to vary either the capacitance or the inductance. And here we are using a bar cap, so a variable capacitor. And that's actually done just by turning a couple of plates. So if you go ahead and look up how a capacitor works, you'll notice that typically they give you like two plates that are sitting on top of each other. And they say, it's dependent on the area, the dielectric between them, and how far apart they are. Dielectric just meaning like the material between them. Is it air, or is it some sort of special hair gel, or something like that, right? But if we turn these plates, we turn them. So if you imagine my hands here, as I turn one this way, you can see that there's less overlapping area between the two plates. And so that's actually going to change the capacitance, okay? So we're modifying the area in this bar cap. We're actually moving how many of those plates are actually directly over top of each other. And by doing that, we can vary the capacitance, right? And so that is the purpose of that component, and Stephen is designing a beautiful knob to fit onto that component. So let's go ahead and take a look at his design. I think we've got it here as a 3D model, so we can actually take a look a little bit more close up at this design, at this model. And this was done in Tinkercad. The final version was actually done in Fusion 360. And Tinkercad's got this really cool tool where you can actually import your models from Tinkercad into Fusion. So as you're working on your 3D design, 3D modeling skills, if you decide, hey, I am done with Tinkercad, I'm ready to step up into the high level Fusion 360, you can do that. You can do that from here. So let's go ahead and take a look. So this is the knob that Stephen actually made. And we can see that there's a little space here. This space was actually designed based on the connector that was on that bar cap. So there was a little stud that stuck out. And so Stephen actually designed a little cavity and cut it away out of this sphere to actually, or out of the cylinder, sorry, to actually fit on top of that nub. And the idea was that it was going to be a tight fit. So the tolerances, it's actually the exact size, and there's going to be a little bit of extra bit of plastic on the edge because of some of the principles of 3D printing and 3D design. It's actually going to be just a little bit smaller than the actual knob, but plastics are a little bit flexible, and so it's actually easy. It was easy enough to pop that knob on and have it kind of grip on the extrusion, the little knob that was on the actual bar cap that was kind of small. So that is how Stephen designed his knob. He did a fantastic job, and so we wanted to give him a shout out. So really good work, Stephen, on your knob here. So let's go ahead, and we're going to be moving very shortly into our interview. But I just wanted to mention again that for these projects that you're submitting, remember that some of the best projects that you're going to work on are projects that, you don't just sit down for 30 minutes, you come up with the idea, and then you say, okay, great, and then you just put it together. And no, that's not typically how things work, right? We normally, it's from coming back to a project. That's how you really get closer and closer to something that's really good, right? So you don't have to expect to get everything completely perfect on your first try. Of course, if you've worked on projects before, you might have heard the term measure twice, cut once. So don't rush into something too quick. Take your time, measure things out, make sure that everything's going to fit together before you go and cut, I don't know, $1,000 piece or order a couple $100 part. Make sure that everything that you're doing is purposeful and correct, right? But at the end of the day, things aren't always going to go perfectly, and that's why we come back and we revise our projects and really try and get them as good as we can, right? Based off the feedback of each trial, right? And that's just involved with learning from your mistakes, and that's not just kids learn from their mistakes, adults learn from their mistakes too, right? Sometimes we learn a lot from big mistakes, right? So it's an important part of the process of coming up with a project. And if you remember some of the projects from yesterday, those were super detailed, and those were done by students that repeatedly came back to the same project and kept asking the question, how can I make this better? How can I make this better? Okay, so let's go ahead now, and we are going to jump into our interview. So I will be back in a few minutes.
Hi everybody, this is Coach Greg at Zen Maker Lab. We're going to be doing these Unleashing Summer Awesome activities with the staff here. So I'm going to start it off with the floor ball. Here we go. These are things you can do with the shield.
Ever since I got this face shield, I noticed improvement in my juggling. Stay active, try local.
All right, so that's Unleashing Summer Awesome, the Monkey Bar Challenge. Stay active, try local. Stay active.
Try local.
Here we go, stay active everyone. Stay active, try local.
Early on, we realized that it would inevitably spread to Canada. We had to ask ourselves what we could do to keep our population safe.
My mom is a nurse at Lionsgate Hospital, and her concern is the rapid spread of the virus across the wards, so I decided to create a face shield for her to keep her safe from COVID-19.
And GladSend donated what they could. A lot of hospitals in Canada did not have enough PPE.
At Zen, we're a team of makers with backgrounds in engineering, business, and design. We believe that great ideas are only worth the action taken.
We noticed that these face shields were being made in a way that wasn't environmentally friendly. We thought, wouldn't it be great if we could make one that was recyclable, that was biodegradable, that could protect people, as well as protect the environment.
The power a community has to create health is limitless when we work together.
Hi everybody, this is Coach Greg at Zen Maker Lab. We're going to be doing these Unleashing Summer Awesome activities with the staff here. So I'm going to start it off with the floor ball. Here we go. These are things you can do with the shield.
Ever since I got this face shield, I noticed an improvement in my juggling. Stay active, try local.
All right, so that's Unleashing Summer Awesome, the Monkey Bar Challenge. Stay active, try local. Stay active. Try local. Here we go, stay active everyone. Stay active, try local.
Welcome back to the Design Make Play Show. My name is Siri Jones, and I'm really happy to have a special guest today who's been involved with the Zen Maker Lab for a number of years now, Dennis Schweers. Now, Dennis came by our lab, I think it was at least 2 or 3, maybe even 4 years ago, early days. He's helped out with all kinds of different projects that we've been working on. He's a super smart guy, all kinds of cool inventions, and he was working with Nuco and all these other kinds of cool projects. He also was one of the contributors to the community 3D printing program, which we really appreciate. So you're one of the first to get on board with that and help the community with face shields and personal protection equipment. So thanks so much for being on the show. Today though, we're talking about bees. Tell me a little bit more about what you've been working on as inventor, and say maybe a little bit about your background first and then get into the bees.
I'm a biomedical engineering technologist is my background. I've worked at Children's Hospital Biomedical Engineering for more than 30 years. I've moved on Navy robotics project more recently, and current distraction is my work with bees. Basically, the result of a bit of a joke actually. We went to visit an Inuit art gallery, and they pulled out a print of a bee, and I said, well, there's a piece of science fiction because there's no bees in the high Arctic. Okay. And that led to an idea. Why not? We heat our houses, why not heat your beehives, as being a principal problem. So what I've discovered is that bees often on the West Coast are not surviving as well as they do in colder locations such as Alberta, where you can get typically much more severe winters than we have on the West Coast. But many beekeepers lose their bees during the winter period, and I thought that's something I can possibly do something about. Possibility to provide controlled environment for beehives to make them a more survivable environment. Anyway, so one of the areas that seems to be of critical importance is the humidity in the beehive, and as the temperature falls, the temperature can drop below the dew point, and you can have condensation happening inside the beehive.
You have a cloud kind of rain right in.
Potential rainstorm inside the beehive, which is a very unhealthy thing.
Sounds a little chilly.
Yeah, very definitely. So that took us through the process of the first generation environmental controller, which you can see here on the table. Huh. And what we will do is have a humidity sensor that would be dropped inside the hive, and we would monitor the humidity, the temperature, and calculate the dew point. And before we approach the dew point, we would turn on a heater to prevent condensation from happening inside the hive. So in order to test the system, I've built a bee laboratory
Nice.
Just for example, this is a very conventional beehive box.
Yes.
And what you have are these frames that fit inside the hive, and the bees will go ahead and they will actually build comb on the inside. So it's a couple of pieces of honeycomb when the bees are allowed to just build in free space. If you have any available volume, they'll fill it with comb. Not necessarily where you want them to, but typically you'll place frames inside the unit to encourage the bees to build the honeycomb on these surfaces.
Yeah.
But anyway, the conventional box is effectively a black box experience. You can't see what's going on inside. And what I wanted to do was be able to test an environmental controller, actually look at where condensation happens. And so what I've done is started working on a laboratory, basically, that will allow you to place the conventional frames inside and have these refrigeration panels that will allow one to cool the unit, drop it below the dew point, and observe the dew formation. And we'll have acrylic windows on this package to make a controlled environment.
Nice.
And so we'll place instrumentation such as humidity sensor in the appropriate locations. We can test the overall design with the laboratory that will allow you to observe what's actually happening. Anyway, so this is the first generation controller using repurposed discarded electronics. Here at the Zen Lab, I was able to make use of laser cutters and the equipment available. And we're also using, for the first time, Tom Doed's compiler package to put the software together for this system. So we're doing that for the very first time, and
looks like it's
an interesting collaboration.
Yeah. Oh wow. And when do you think this? We don't have too much more time, but when do you think this will go live in terms of having a working prototype?
It works now.
Oh, it works now.
It works now.
Okay.
It's a matter of all software development programs. That, it's a continuous process of reshaping. But
when do you try it out with some bees?
The first order of business is not to subject the bees to torture, but I will test the overall performance of the system, and I will start by placing a second unit in an actual beehive so we can look at the humidity profiles, and possibly this winter we may be able to look at the potential of controlling with some additional heat.
Oh, nice. Okay, well, hopefully we'll have you back on another segment to show us how it progresses along, but maybe in just the final 30 seconds or so, any tips that you would give to kids and youth that are out there about how to be an inventor like yourself? Like what are some of the things that they can do to try to get down that pathway?
Stay curious.
Stay curious.
That's really the start of all things. How do things work?
Yes.
And I find the history of invention. How did people do things for the very first time? You investigate the history. That's a very exciting way to understand the original concepts of which people built on. And
okay, well that's great advice. I think we'll have to wrap it up there. Thanks everyone for going to the Design Make Play show. Thanks very much Dennis Sweers for being on the show. Inventor extraordinaire And I really hope that we have a chance to have him back on the show to see this progression. Very cool idea. Bees played a super important role. It's not just for the honey and everything, it's also pollination of crops and all kinds of things. So is that correct? It's also,
Yes.
yeah, so I think this is more than just sort of like a little, like a project on the side, it's something that can make a big difference. So thanks so much, Dennis.
Thank you, sir.
We will all see you tomorrow in the next version of our Design Make Play show, starting every Monday to Friday, 8:30 a.m. Pacific time. Thanks for joining us and have a great day.